All right, ready for another deep dive. This time into QLSV theory. And wow, you weren't kidding about a lot of material. A
Yeah.
whole booklet, appendices, even some bonus notes.
Yeah, it's a pretty ambitious project.
For sure.
They're trying to tackle some of the biggest questions in physics,
Yeah.
like how quantum mechanics and general relativity and information theory all fit together. It's a big puzzle.
And they're doing it with this really wild idea, right? The
Mm-hmm.
universe is this like infinite sea of possibilities,
Yeah.
and it's all represented by bit strings.
Right.
It's like it's almost like the universe is this giant computer
Right.
program,
It's a good analogy, yeah.
and each bit string is a different line of code.
That's the basic idea. And QLSV uses these bit strings to describe everything
Wow.
from black holes to our own observations, but
Okay.
instead of just like listing out equations, right?
Yeah.
The booklet tries to build a visual model,
Okay.
which is where these four representations come in, Q, L, S, and V.
Okay, so let's unpack those. Q is for the quantum representation,
Oh, yes,
right?
yes, exactly. So Q represent the entire multiverse,
The whole shebang.
the whole thing. Think of it as this abstract space
Okay.
filled with infinite bit strings, each one
Okay.
a potential universe.
Okay.
And the theory even assigns probabilities to these bit strings.
Oh, interesting.
So some universes are more likely to exist than others.
So some bit strings are like cosmic duds,
Mm-hmm.
and others are like prime real estate for a universe to pop up in.
Exactly. Some might have physical laws that just don't make sense,
Right.
while others are more stable and could potentially support life as we know it. But here's where it gets interesting. L, the linear representation.
Okay.
That zooms in on your reality.
So while Q is the whole enchilada, L is just my little slice.
More like your own personal thread,
Okay.
like woven from the fabric of Q. Right. So as you experience life, you make observations, you interact with the universe, you're adding new bits to your L. You're essentially writing the story of your own personal universe.
That's a pretty empowering thought.
Yeah.
I like that. That our choices and experiences are literally shaping the reality we inhabit.
Right.
But where do S and V fit into all of this?
This is where QLSV gets really mind-bending. S, the superficial representation, is this 2D surface
Okay.
that acts as a boundary to the universe.
Okay.
But instead of being just a simple surface, it's holographic. It's encoding information about the entire 3D universe.
Wait, so you're saying that our 3D reality is like a projection from a 2D surface?
Precisely.
Like a hologram?
Like a hologram, yeah. Imagine the surface containing all the information about the universe.
Oh.
Like its curvature, its mass, its energy, all encoded in this complex geometric pattern. And that projection, the 3D space-time we experience, that's V, the voluminous representation.
Okay, my brain needs a minute to process this. So we've got Q, the source code of the multiverse, L, my personal thread of reality, S, the blueprint surface, and V, the projected 3D world we live in.
Yeah.
But how do these representations actually interact? Like, how does information flow between them?
Yeah. That's where the booklet dives into specific examples. So, let's take the formation of a star.
Okay.
In the Q representation, you have all these potential bit strings representing stars of different masses and sizes.
So in Q, there's a bit string for a tiny star, a bit string for a giant star, and everything in between.
Exactly.
Okay.
But, because of the laws of physics and probabilities,
Yeah.
some of these configurations are more likely than others.
Sure.
Now, imagine you observe a star in the night sky.
Okay.
That observation, according to QLSV, is like plucking a specific bit string from Q and adding it to your L, your personal reality.
So my act of observing the star is influencing the very fabric of my own universe.
It's a very participatory view
Ah.
of reality. And that's one of the core ideas of QLSV. Now, this information about the star, its mass, its location, this gets encoded onto S, the 2D surface.
Okay.
It might manifest as a point of high curvature or a specific geometric pattern on S.
Like a bump on the blueprint that tells the universe, hey, put a star here.
Yeah, exactly. And finally, that information on S gets projected into V, our 3D spacetime, as the actual star we see, with its gravitational pull and all its other properties.
So it's like a chain reaction.
Right.
My observation collapses the possibilities in Q. updates my L, writes new information onto S, and ultimately manifests as a change in V.
Exactly. And
Yeah.
this process, according to QLSV, is happening constantly
Yeah.
on all scales, from the formation of galaxies down to the interactions of subatomic particles.
This is already getting mind-blowing.
Yeah.
But I'm curious, does QLSV have anything to say about those big cosmic mysteries,
Yeah.
like dark matter and dark energy?
Yep.
Can it explain those with this framework of bit strings and representations?
That's where things get even more interesting. And we start to see the potential of QLSV to offer new insights into the universe. But we'll save that for the next part of our deep dive.
All right, listeners, hold on to your hats. We're about to venture even deeper into the strange and fascinating world of QLSV theory.
So, we spent part one laying out this framework of 4 representations, Q, L, S, and V, that QLSV uses to describe the universe.
Right.
But I think one of the most intriguing aspects of this theory is how it tackles the role of the observer.
Right. This idea that that we're not just passive bystanders watching the universe unfold, but active participants shaping reality with our observations.
Yeah,
A pretty radical concept.
it is.
And I'm really eager to hear how QLSV explains it.
Well, it all boils down to this concept of measurement, right?
Okay.
So in QLSV, every time you make an observation, it's like plucking a single thread from the infinite tapestry of Q, the multiverse.
So my observation acts as a filter, collapsing the wave function.
Right.
And narrowing down the possibilities from this vast sea of potential universes.
Exactly. And that act of choosing, of collapsing the wave function,
Yeah.
that's what adds a new bit to your L, your personal thread of reality. It's like saying, out of all the possible universes where this event could have happened this way or that way, I'm experiencing the one where it happened this way.
I see.
Right.
But what defines a measurement in QLSV?
That's a great question.
Is it just something that conscious observers like us do?
Yeah.
Or can anything in the universe make a measurement?
Yeah, that's a great question.
Yeah.
And the booklet does acknowledge
Yeah.
that the definition of measurement is still being debated within the framework of QLSV.
Yeah.
But the general idea is that any interaction that extracts information from the universe can be seen as a form of measurement.
So even on the subatomic level, particles are constantly measuring each other and influencing the fabric of reality.
Precisely. Think of 2 particles colliding.
Okay.
That interaction extracts information about their momentum, their position.
Okay.
And that information exchange can be seen as a measurement.
So it's this constant dance of information flow weaving together the tapestry of the universe.
Yeah, it's beautiful, isn't it?
It is. It's pretty amazing.
Yeah.
But the booklet also mentions different types of measurements: classical, quantum, and superquantum.
Yes.
What's the difference between these, and how do they impact the different representations?
So it's basically a way of categorizing the level at which these measurements influence the flow of information between Q, L, S, and V.
Okay.
Right? So classical measurements are the most straightforward.
Right.
Think of flipping a coin.
Okay.
Before you flip it, there's a 50-50 chance it lands heads or tails.
Right.
Once you flip it and observe the outcome, you've made a classical measurement. It's added a definite bit of information to your L. And that outcome then gets encoded onto S and projected into V.
So classical measurements are basically just everyday observations that solidify a specific outcome from a set of possibilities.
Essentially, yeah.
Okay.
But then we get to quantum measurements, and that's where things start to get really strange.
All right.
So QLSV suggests that quantum measurements don't just depend on the past, but potentially on future possibilities as well.
Wait, are you saying my observation in the present could be influenced by something that hasn't happened yet? That sounds like time travel.
It's not quite time travel, but it does challenge our linear understanding of cause and effect.
Sure.
Right. So QLSV proposes that the act of measurement might not simply collapse the wave function, but could actually involve selecting a bit from Q based on future constraints.
So it's like the universe is somehow taking into account what will happen when determining what does happen.
Yeah, it's a mind-bending concept.
It is.
And it raises all sorts of questions about free will and determinism, right?
For sure.
But one way to think about it is that in the quantum realm, the past, present, and future might be more intertwined than we realize.
Okay, my head is spinning a bit.
Sure.
So classical measurements are straightforward. quantum measurements get into time-bending territory.
Yeah.
And
Yep.
then there are super quantum measurements.
Super quantum measurements.
What are those?
Those are the most radical and speculative aspect of QLSV.
Right.
So the theory suggests that it might be possible to not just choose a bit from Q,
Right.
but to actually modify Q itself.
Hold on. Are you saying we could change the fundamental probabilities of the multiverse?
Yeah.
That sounds like something straight out of a science fiction novel.
It's definitely a mind-boggling concept.
Yeah.
And the booklet is very clear that this is highly speculative, right?
Yeah.
It doesn't offer any concrete mechanisms for how this could work. And it acknowledges that we are nowhere near the technological level required to even test these ideas.
So super quantum measurements are more like a theoretical possibility
For now.
yes, than something we could actually do.
Right. But it's a tantalizing possibility, isn't it?
It is.
The idea that we might not just be observers of the universe, but potentially architects of the very fabric of reality.
That's a lot to process.
It is.
And it definitely raises more questions than it answers.
Sure.
But that's what makes this theory so fascinating.
I agree.
It pushes us to confront the limits of our understanding and to imagine possibilities that might seem impossible at first glance.
Exactly. And even if some of the more speculative aspects of QLSV turn out to be incorrect, the framework it provides for thinking about the universe, information, and the role of the observer is incredibly valuable.
I agree with that.
Right. It's a new lens through which we can view some of the biggest mysteries in physics.
Well, speaking of mysteries, does QLSV offer any testable predictions? Can we actually observe these interactions between QL, S, and V in the real world?
That's a crucial question.
It is.
And the answer is surprisingly yes.
Okay, free.
QLSV does make some predictions that could potentially be verified through experiments.
Oh, very cool.
And that's what we'll explore in the final part of our deep dive.
All right, listeners, get ready for the grand finale.
Yes.
We're about to find out if QLSV is just a beautiful theoretical framework or if it holds the key to unlocking some of the deepest secrets of the universe. Well, we spent the last two parts of our deep dive really exploring some pretty wild concepts of QLSV theory.
Yeah.
I mean, multiple universes, personal realities, a holographic blueprint of existence. It's a lot to take in.
It is. It really challenges our fundamental assumptions about, the nature of reality.
It does. It does.
But, a theory is only as good as its ability to explain what we observe. So does QLSV hold up to scrutiny? Can it be tested?
That's the million-dollar question.
It is.
Can we actually see evidence of these four representations, these bit strings, these quantum measurements, in the real world?
Well, surprisingly, yes.
Okay.
QLSV does offer some testable predictions.
Okay. All right.
And one of the most promising areas is in the study of dark matter.
Right. We touched on this earlier.
Yeah.
The idea that dark matter might be represented by regions of high information density on S.
Yeah.
The 2D holographic surface, even if it doesn't have a corresponding mass or curvature that we can directly observe in our 3D spacetime.
Exactly. And if that's the case, then the distribution of dark matter in the universe should have a unique signature.
Okay.
A pattern that reflects the structure of S.
So by mapping out dark matter, we could indirectly get a glimpse of the holographic blueprint of the universe.
That's the idea. And astronomers are already using techniques like gravitational lensing.
Right.
To map the distribution of dark matter with incredible precision. Who knows, maybe someday they'll find patterns that match QLSV's predictions.
That would be a huge validation of the theory.
It would.
What about those bit flips we discussed?
Right.
Those cross-thread interactions in Q, where information seems to jump between different potential universes.
Yeah, that's a trickier one to test. But QLSV suggests that these bit flips could manifest as non-local correlations between particles.
Okay.
Even if they're separated by vast distances.
You're talking about quantum entanglement, right?
Precisely.
That spooky action at a distance that Einstein famously struggled with.
Exactly. Entanglement is one of the most bizarre phenomena in physics.
It is.
Two particles, no matter how far apart,
Yeah.
can be linked in such a way that measuring the state of one instantly determines the state of the other.
Right.
And QLSV offers a potential explanation.
Yeah.
Those entangled particles might be connected through these cross-thread interactions, sharing information instantaneously across the multiverse.
Okay, now my brain is really starting to hurt. But it's a good kind of hurt.
I know what you mean.
It's the kind that comes from grappling with ideas that push the boundaries of what we thought was possible.
And that's the beauty of QLSV. It's a theory that really sparks the imagination. It forces us to rethink our place in the cosmos and the very nature of reality itself.
It does, it does. But what about those super quantum measurements? The idea that we could actually modify the fundamental probabilities of the multiverse. Is there any way to test that, or is it purely in the realm of science fiction?
Well, for now, testing superquantum measurements is it's beyond our technological capabilities.
Sure.
But the theory does suggest that they would produce some truly mind-boggling effects. Imagine a measurement that could create a new singularity on S,
Okay.
which would then project into our 3D reality as a brand new black hole.
That's a pretty high stakes experiment. I think I'd prefer to leave that one to the theoretical physicists for now.
I agree. But even if we can't test it directly, the fact that QLSV even raises the possibility of such a profound interactions with reality is it's astounding. It opens up a whole new realm of exploration, challenging us to consider what might be possible if we could truly harness the power of the quantum realm.
So we've got dark matter maps, quantum entanglement experiments, and maybe someday even super quantum measurements. It sounds like there's a lot of potential for QLSV to be tested and refined in the coming years. But even if it turns out to be wrong, I have to say it's one of the most thought-provoking and intellectually stimulating theories I've ever encountered.
Yeah, I think what makes QLSV so compelling is that it offers a framework for unifying so many different areas of physics. Quantum mechanics, general relativity, information theory, even cosmology. It weaves them all together into a single tapestry.
It's a glimpse into a deeper level of reality where information, geometry, and consciousness might all be interconnected in ways we're only beginning to understand.
And it reminds us that the universe is a vast, mysterious, and endlessly fascinating place. We're not just passive observers in this grand cosmic drama. We're active participants, shaping reality with every observation, every choice, every interaction.
So to our listeners out there, keep those minds open, keep those curiosity circuits firing, and never stop exploring the infinite possibilities that the universe has to offer. This has been a deep dive into QLSV theory. We'll see you next time for another plunge into the mysteries of the cosmos.